Appreciate you joining me today. This is Steve Randolph, CTO of Harbormaster. And Harbormaster is a platform for generating projects. It's a model-driven platform, and the goal of today is to demonstrate from a simple YAML file how we can generate for a number of different tech stacks, an entire application. We'll generate the YAML file for a target CI platform, and then we'll also execute that YAML file on that platform to build and test, and then build a Docker image, and then we'll pull that Docker image, and then we'll run the application. So you can see from beginning to end, what is it actually doing, what's the platform doing, and how much code is it actually generating for you, code, application code, as well as the the project files necessary to be considered, a fully executable project. So if you'll allow me, the first thing you're going to need to do is install Harbormaster. And what we'll do first is we'll go to the website and we'll have to register ourselves as a new user. When you register yourself as a new user, you'll be given, I won't go through the process here, but you'll be given an API token. And that token is what you're going to need in order to run Harbormaster from the command line. The command line version is the community version, is the free version. And I figured we would demonstrate that today rather than the pay version. That way it'll give you a flavor for what's the capabilities, what's it look like, and how can I use it. Importantly, what you want to also take a look at is applying your own personal Git access token. Whether you're on Bitbucket or GitHub, you can create an access token that will be used in order for us to connect and commit the entire project to your Git repository. You'd want to use that instead of using a password, because eventually passwords will not be allowed to be used. So you can do that. So again, register yourself as a user, apply a personal Git access token, and when you do that, Harbormaster will show you that you can cut and paste, show you your API token, and you want to store that off somewhere, because we're going to need that eventually. We could clearly run from here the ability to generate code. We have projects. You can create a project, you can load that project, etc. We can certainly select one of a handful of a number of different tech stacks. We can load up models from here and all those things, and we can simply generate the project. But I wanted to do it from the command line today, and then in another video I'm going to take you through using the user interface. I also want to take you through some of the architecture behind Harbormaster, so you can get an understanding as to what's actually going on. How is my YAML file being interpreted? What is it doing with my model? And if in fact you decided to create your own tech stack, I mean, we have some, but you certainly could create your own. You could download one of ours and modify it, upload it, and make use of it. Just to take you through what's actually going on inside one of these tech stacks, what's it composed of, and I'll take you through that as well in another video shortly. But for now, why don't we go ahead and head out to the command line. And what you would do here is, you would basically install Harbormaster this way. I already have it. But once you've installed Harbormaster, from here, you would be able to initialize Harbormaster with your token, right? You could come here, you could type in it, and then you could go ahead and type in your API token that was assigned to you earlier. And what that's going to do is it's going to cache your token. You won't need it again, need to assign it again. It'll cache your token, and that way every time you run a command up against the back end, the token will be applied just to verify that the user and your access is appropriate. When you're running the command line version, you could be running it against a different remote server than the one that's the default, the one that Harbormaster keeps up in AWS. as a SaaS platform. We keep it up there, and anybody who's using the command line interface is actually talking to that one. But if in fact, whether you had the enterprise version or another version and you had it installed somewhere else, maybe locally on a different machine, you could initialize your token against that machine as well. But for today, I've already initialized, I've already installed Harbormaster. Let's go ahead and get started. So the first thing I want to talk about is that Harbormaster is a model-driven platform. That means in order to share with the platform your application, right, you've got technical requirements, right, what tech stack you want to use, what database you want to use, your Docker parameters, your cloud parameters if you have them. You're going to be wanting this to spin it up and generate code for Kubernetes. There's all sorts of things that have to do that are technical. But you also have non-technical things, and those non-technical things are shared with the platform through what we're calling a model. And I'm sure most of you are familiar with what a model is. We support many different forms of a model. We can use UML. Right now we're using the Eclipse modeling framework, the .ecore extension. It could come in the form of a simple JSON file. It could actually come as a SQL script. We're going to be able to decompose the SQL script, looking at the tables and looking at the columns and the declarations and certainly foreign keys to deduce the associations. We can deduce a model from that as well. We support YAML, XMIs, and sort of an older form, if you would, of UML, and that allows us to take applications that were built many, many years ago and be able to regenerate those using that XMI file onto a newer, more modern tech stack, if you would. But we also allow you to point to a Git repository. I don't have that here, but you could point to a Git repository containing Java code. And you also could load up a jar file, and it will decompose that looking for the Java beans. You tell it what package it's in, and it will go ahead and decompose that, and it will also deduce a model through using reflection as well. So there's a number of different ways to share a model with the platform, but it's necessary. We don't, otherwise you get hello world. We need to know something about what you're trying to do. There's technical requirements. I'll get to those in a second. And then these are the ones that are non-technical. So for this, it's a simple model. It's a bowling league. There's a player, there's tournaments, there's matchups, there's games, etc. Like, this is just to give you a flavor as to, how simple it is to create a model, create the entities, define the attributes, assign the associations between the entities in the model, etc. And again, you could have done that in a JSON file, a YAML file, but here I'm in Eclipse. So I did it as a Eclipse ecore file. The next thing to take a look at that's important, it's very critical and it's crucial. Just like you're used to using, if you're used to using Docker, if you're used to using HashiCorp Terraform, you've gotten used to the notion of using YAML files to describe what it is you need of the underlying system. And in this case, using Harbormaster is no exception. Right? It's as simple as me telling the system itself that I want to use the Rails tech stack. Again, through documentation, you can read about what it means to use the Rails tech stack. But you can, if you've used Ruby on Rails, you would probably have an idea as to, what does it mean to do that? If you've ever built a Rails application, you'd realize, all the code necessary. Rails will generate some, but not everything of what you need if you can answer enough questions and provide it with enough information. You certainly can't share a UML file or a model, but you can certainly tell it some things about the entities that you need and those sorts of things. But as you'll see when we generate this particular project, we're generating so much more than you would ever get with a standard Rails application. But it's as simple as telling the Harbormaster backend with this YAML file that we want to use Rails. What we're doing here is we're telling it that we want to use this model, and this model, this ecore file, has already been published to Harbormaster. I use this name when I did that, and now it will affiliate this name with that model when I want to tell it to generate a project. Some of the more important aspects as well are that I can define options that are used within the tech stack that you'll see eventually as we go along here, how these get applied during project generation time, right? These are my Git parameters, how am I going to get this project into a repository? Where is it? What's the repository name? How do I get to it, etc. Docker's the same way, right? The repo name, where's it hosted, username, and those sorts of things as you'd expect as well. But also what it supports is the ability to tell it the target CI platform, CI/CD platform. In this case, we're using Circle CI, but you see we support other ones. We support Jenkins and GitLab, Bitbucket, AWS, Code Build, CodeShip. So we can tell the Harbormaster that we also want this project to have the right YAML file or files affiliated with a specific CI platform, because that's where we're going to eventually do the building and the testing, right? So in that YAML file will be all the code necessary to spin up the right image, right? If we're doing an Angular stack or a Go stack, Ruby on Rails stack, whichever, it's going to be able to have all that generated. Again, we'll step through that. I'll show that to you. In this case, we're telling it that we're going to be using the application port is 8088. We also could tell Harbormaster that we are going to be using an artifact repository. We support either JFrog or Nexus to keep things simple. Today, I'm going to just disable that. We can also tell it that we're going to be using Terraform. And when we say that we're using Terraform, we are saying that we want to spin up infrastructure as well, right? Whether it's on AWS or Google, Azure, Nutanix, we support that as well. We're targeting not just the project being generated in it, not just being built in it, not just sitting in a container, but it actually being spun up in an execution deployed environment. And that's something that's very different, right? I don't think you're going to see anybody else is doing that right now. And then again, we can denote Kubernetes, right? Are we going to have this sitting in a Kubernetes cluster? And again, we provide enough information to do that. We'll do everything in the background that needs to be generated. We do all that through Terraform as well. But all the files, configuration necessary to spin up a Kubernetes cluster, we'll handle that as well, and that's turned off. So this single file is our way of communicating with Harbormaster and just saying to it, here are the technical requirements of the application. The model are the non-technical requirements, and these are the technical requirements, and it brings them all together, and that's important. So what I'm going to do first off is I'm going to go to GitHub, because I'm going to generate a project and I'm going to commit it here, and I'm going to create a repository. Let me see here. Let me just give it a name, and it should be the same name that I had back here, just by reference, by the way, just so you know. Right here, that's the name of the repository. It'll be the same here. And let me go ahead and create that. And it'll be an empty repository. So let me come out here now to the command line, and I can let me just do this here first, if you'll forgive me. See what I got in this directory for files. There we go. So I've got different project files already configured just for the sake of testing. And I'm going to communicate with Harbormaster and tell it to generate a project using this file right here. Okay. So eventually, let it do its thing in the background. It won't take very long. Eventually, we're going to have files here, right? We're going to have a lot of them. We're going to have tens of thousands of lines of code. The ability to create, read, update, and delete, everything that was in the model, persisted, obviously, have a user interface with it. This is Rails, so it'll all be self-contained. But if we were using, a different tech stack, right? If we were using, and I'll show you some of the tech stacks that we do support, There's quite a few right now, and the list is growing because the tech stacks are separate from the platform. I'll explain that in a different video, but it allows the tech stacks to be authored separate from the actual platform itself. So we support, Go tech stack. We have different versions of Angular. We have the Apollo GraphQL, ASP.NET, AWS Lambda to Django. We support Google Functions. Ruby on Rails is the one we're using now. A couple different Spring tech stacks, and we use the Spark micro-web framework as well, which struts too. So there's a number of different tech stacks to choose from. Again, I'll get into the ability to author your own tech stack in a different video, but we're going to go ahead and let this finish. Let's see where we are. It's still out there humming along. Once that's finished generating everything, it should get committed here. And then what I'll do from here is I'm going to go to Circle CI, because that's the CI platform that I asked it to target in generating the correct YAML file to execute out there. I'll go out there. I'll associate this particular repository with a pipeline on Circle CI, get it running, and then we're going to go ahead and build, test, and then and containerize the application itself. So let me go ahead and see where we are right now. Okay, we finished. Great. So let me go back here and let me refresh just to see where we are. Awesome. So we got a lot of stuff generated here. It's mostly sitting in this directory here. As you'd expect, it's got some structure. Ruby Rails expects it to be sitting in a certain structure, and that's the way it gets output because of the tech stack and the way the tech stack is defining the mechanisms for how files and where they should be written to, all self-contained. And again, I can go through. We're going to go through that in a lot of depth in a different video. But right now, it's all generated. Let's go out here and let's go ahead and set the project up. And it's going to ask me if you already have a config.yaml. The answer is yes, we generated it. So let's go, and I may have to kickstart this manually once this gets running. Let me see where we are. Yeah, so let me go ahead and change this to master, and let's go ahead and run the pipeline. Okay, now it's running, and I'll take you through the config.yaml in a second, but let's go ahead and see if we can pull some of this down, if you don't mind. I wanted to take a look at, see if we can take a look at some of what was generated. Okay. Okay, so all this was generated, right? We can step through here and we could take a look at that. We have a Docker file that was generated. All of this code was generated, right? All the controllers that you'd expect. We've got helpers, we've got the models generated, we've got the views generated for each of the entities that were found on the model to be able to create, read, update, list them. That's all generated as well. In the DB section, we're going to have an initial way to migrate and set up the database. We generate a way to see the database. We'll see that when we run it. And we also have generated test controllers to be able to execute just core functionality for each of the entities. And that will be run during the CI phase up on Circle CI. So there's a lot of code there, and again, I don't, I don't know how many lines it is off the top of my head, but typically what we find for clients is depending upon the size of the model, this is a small model. Models typically are many times bigger than this. We're generating, in excess of 100,000 lines of code. Now, lines of code don't mean anything. We're not inferring that it's the whole application or that it's all the complexity, but it's getting out of the way the stuff that, again, for a senior developer, we've written these things before by hand. At some point, it'd be great to have them just appear, right? So I can get on to leveraging these core capabilities to build on top of them. the functionality that really matters for the application, right? Being able to create, read, and update, delete these things is typically not the core for a fairly sophisticated application, but they're necessary. So we're generating all that necessary heavy lifting stuff that it just needs to be there, but it gives the developer the time, more time and freedom to work on what we're calling the innovative things, the things that really matter and make the difference for the application compared to your competitors or whoever you're viewing as um, the difference between what you're doing and what somebody else is doing. Again, that's important, and that all took place in a short period of time. So let's go back out to Circle CI. And let's actually see what's happening out here, right? So it's doing a build test, and if I step into here, it's going to take some time. We can follow along with what it's trying to do. And again, it's setting things up. And what it's doing under the covers is it's mimicking the sort of the project build process that takes place when you're using Rails. You could tell Rails to create your own project. So we do that, but then we take everything we generated that Rails doesn't know anything about, and we lay it on top of it, right? So now we have, what Rails wants to provide for free, a lot of the default files, whether they're environmental configuration, just standard Ruby on Rails things. But then we're putting on top of that the things that need to be there specific for the application. And those are all found in the tech stack, and those have been generated, and that's part of this process as well. And this is still running. And what's going to happen is, as well as it's going to go ahead and test it did it right here. It's going to go ahead and test the controllers, 10 runs, 20 assertions, no failures, no errors, nothing skipped. So that test succeeded, which is great. And when this is finished, which it is now, we can go back to the flow. And now it's going to build the Docker image. And the Docker image will be pushed to the repository that I specified. It'll be out here at some point. When it's done, I'll do a refresh and we'll see it. Then I'll go and pull it. I'll run it. We'll go to the browser, see the application, and we're done. And again, that model is important. It's your context, and it's separate from the tech stack. I could have taken that same model and generated on any of the other tech stacks we are supported. We would have gotten the same functional results. We would have gotten the same build, test results, etc. We would have contained it as we'd expect. Of course, the code's all different because it's going to be for a different tech stack, different language, with different underlying support for, whether we're using MongoDB, using Hibernate to store in a relational database. However we're doing it, it'd be different because of the tech stack. But the model is consistent and the same, and that's important. So from an enterprise perspective, what we're showing here is that automation engineer, that person who's up front for getting things set up, they can do this now on behalf of a team. So whether the process is, the enterprise architecture team is the ones who take a look at the particulars of a project as they come through the pipeline for a particular line of business or whatever they're overseeing for IT. Part of that is being able to share that with an automation engineer who can either take a model if provided with the request, or that person could build the model from the requirements real quick, again using one of the formats we talked about, and now they can generate the beginnings of the project. So projects don't start with the typical sprint zero. They now start with an application, a project in a container that is now ready to be expanded upon, right? Ready to be certainly built upon and finished. And we find typically that it depends on the size of the model and what the team considers to be finished in terms of a version in some way. But we're talking weeks, minimum weeks, and it could be months in some cases, but minimum weeks are just shaved off because we're able to do this right now. Now, the beauty of it is that everything is templatized. I can download it. I can actually, and again, another video, I'll run through this. You can see exactly what is going on and how a file got created, how did that code get output, and if something needs to be changed, improved upon, removed, or whatever, it can be done so right there, right? So now You can take a tech stack and you can sort of tailor it for your needs as an enterprise, right? Whether you've got a bake-in security, you've got your own way of doing logging, everything that comes through as a CRUD request needs to be put onto a queue for the sake of it, whatever the purpose is, whatever it is you need to do. Now you've got one place, and now every time an application that's generated, either in general or for a particular tech stack, will have that functionality already baked in. Right? The easy part is, a CSS file. Now you got standards in terms of your look and feel. It goes even beyond that. So every single thing that gets generated for a project is going to be sitting in a template file. Some of these tech stacks have dozens to many, many more than that. But that's important because that's the difference between one tech stack to the next, is that it's the templates. And template files sit in a provided to the platform in a zip file. So you could download it, unzip it, review it. The templates, by the way, are using Apache Velocity. Uh, so that's the template engine, well understood, been out for many, many years. It's a very easy to understand syntax, Java-like in nature. And what is going on during generation time is each of these templates are being run through Apache Velocity. Any macros it references that are part of the tech stack, written for Velocity in a purpose, are executed, and these templates are actually gaining access to the model that we just loaded, right? All these models get turned into a single meta model, right? So regardless of the form of the model, it's turned into a meta model, and that meta model is well documented. We got Java docs and all this stuff. It's well documented, and it's utilized within the template file itself in any way it needs to. We don't know what needs to happen. That's the purpose of it being templatized. It's available. The tech stack author would know at this point in time, I need to output, the class name, a class name. At this point in time, I need to iterate through all the classes, classes attributes. And in this case, I'm going to take those attributes, look at the types, and do something. Again, free reign. It couldn't be more open. We couldn't define it any more openly. But the meta model, everything hangs on the meta model. As long as the tech stack author understands the meta model, what its API looks like, and all, we've got hundreds of helper functions to be able to traverse, a model as a tree-like structure, a query of it, etc. It's going to just simplify how you're able to create your templates. So this is almost completed now. Let me go ahead and step in here and see what's happening. Yeah, so it's just basically and it's just finished. It finished the image. So let me come out here and do a refresh and see if it shows up. It should be the Ruby demo. There it is. It's right here. So now let me go out here, if you don't mind, and I'm going to do a pull on it. So now I'm pulling that image, and I'm going to go ahead and run it in a container. And then I want to access that running application from my browser, and that completes the cycle. Right? I've gone from this idea, I captured it in a model, I expressed it, within and noted it within the YAML file, defining it within the context of a project. I wanted it to be applied to a specific tech stack. I gave parameters that had to do with how I want to see this thing deployed, which CI platform I wanted to use, how can I get this thing pushed into a Docker repository, and now we're going to go ahead and access it. And here we go. So let me kick up another browser window here, and there we go. It's listening on port 3000. I have it, and there we go. There's the application, right? You're going to see the seed data. It's already in there. This was part of seeding the database originally. I can click through here and see that. I can make changes to the things that are in here, just to make sure that they're working. You see it's updated. I can delete it. I can create a new one. And there you have it. That's weeks of work. Again, take this is a small model. Take this model and multiply the number of entities times 5, right? And it's not just the data, it's the associations as well. And that's when things get a little bit complicated, right? When we start to have to accommodate the ability to not only just create the things that are intrinsic to the entity, but the things it's associated with, you understand that it gets certainly a lot more complicated, and that's where the value add of having a tool like this comes into play. So again, I'll step through it real briefly. We started with the notion of a model, and once I captured my thoughts, the purpose of the project, the requirements, etc., in a model, in the form that's in one of the eight forms. I think it's 8 forms that are supported. I then go ahead and I can create a simple YAML file, a project as code YAML file, and I can just tell Harbormaster what it is I need technically. I'm blending the non-technical with the technical, what tech stack I want to use, and those sorts of things. And from there, I'm just telling it to generate, and it does the rest. I hope this was helpful, and I'm hopeful that you'll take a look, give it a try. Even if you don't have an entire new project coming up, but you have an aspect of a project that's being added, you could still use the tool, right? So let's assume that you're building something and it's all about microservices, and someone's defining a new service. Use the tool, right? Whether it's a project for a full-blown application, you're sitting in a war file like it would be for struts or maybe for Spring, or you're really just looking to build out something that's going to be deployed as a microservice, it doesn't matter. You're going to still model it. And as long as the model is concise and self-contained, and you're defining a source to store the data, depending on the platform, sometimes you're telling it the source. Again, it could be MySQL, it could be Postgres, it could be MongoDB. Sometimes it's self-contained. In the case of something like Ruby on Rails, I think we're using the internal SQLite, but you could tell it to use something external as well. But the important fact of the matter is that now you've got all this flexibility on how you can start a project, right? And no one's rushing, right? We're taking our time to design the model because we know we're taking up all this time that would have been spent coding can now be time we take designing and thinking. And I thank you for spending time with me today. I hope you found this helpful. The next video that comes out will be us digging a little bit deeper into what it means to have a tech stack. What are the components? What's the architecture inside? It should give you an idea as to if you wanted to define your own tech stack, what that would mean for you. I think the tech stacks we have here, for the most part, are extremely sufficient. They're the typical application profile containing typical design patterns and architecture considerations for any given language, right? Some are different than others. Uh, Again, supporting things like AWS Lambda would cause us to think differently the way the application is deployed and the way we're going to, what patterns we're going to follow differently than a traditional application that's more web-based versus it being function-driven. But hopefully this gives you an idea of the scope, what we're trying to accomplish. More tech stacks are coming. Constantly working on them. There's going to be vertical tech stacks for Web 3.0, whether it's blockchain, IoT, big data. Want to be able to encapsulate as much as we can up front using the best of breed technologies, templatize them, being able to apply the model at generation time, then will allow a new category of applications to be able to be built out real quickly, supporting a vertical tech stack like something found in one of the Web 3.0s that I mentioned. And then next after that is more industry vertical tech stacks, whether it's for a particular industry like banking, finance, manufacturing, telecom. How do you combine, multiple tech stacks? The fact that you want to use this language, using this vertical, using this Web 3.0 aspect, we're going to be able to do that as well. And again, the whole goal is that your first commit is your best commit. And then if it is your best commit, you'll know with confidence that you can get right on to the stuff you really want to work on, which is the fun, innovative things, the challenging things, and not the things that are more rudimentary, although necessary and considered some of the heavier lifting in getting a project started. So I thank you for your time today.